We are going to go over lesson 3.7, the effects of alcohol. This is learning about slope-intercept form and linear modeling. It is found on page 375 of your book. We're going to move down to where it says 3.7 class. We're going to start right into the problems. A student org you are involved in is planning a year-end party to celebrate another successful year on campus. As chair of the planning committee, you've wisely worked a deal with a local pizza place to provide large pizzas at $9 each. The budget will allow at most $175 to cover the food. And of course, you'd like to know how many pizzas you can get and stay under budget. We'll attack this problem in several different ways. Number 1 asks us to use a numerical calculation. Include all the details and then don't forget to write the actual number of pizzas you can buy. So what do we know? We know that we have $175. And I know it costs how much per pizza? It costs $9. So let's divide that by 9. Use your calculator now. 175 divided by 9 is about 19.4. So my question is then, can I buy 19.4 pizzas? No. I can't buy any more than 19.4 because then I'd be over budget. So what's the most number of pizzas you can buy? 19 pizzas. Let's do this algebraically now. In number 2, they asked me to write an equation that represents the total cost C of ordering P pizzas. What does this tell you about how the cost varies when you change the number of pizzas ordered? So the cost is going to be $9 per pizza. I don't want to just say C equals 9. What do I need to do with that 9? I need to multiply it by the number of pizzas ordered. What kind of variation is this? Hint, you just saw it in lesson 3.6. This is an example of direct variation. The cost varies directly as the number of pizzas we buy. Turning the page to page 376, they ask us now to complete a table based on that. So if I buy 0 pizzas at $9 each, what's my total cost? What's 9 times 0? 0. What is 9 times 5? 45. And I'm going to put my dollar sign up here so I don't have to write it each time. These are all in dollars. What is 10 times 9? 90. What is 15 times 9? 135. What is 20 times 9? 180. What is 25 times 9? 225. What is 30 times 9? 270. Remember that we learned in the last lesson that you can actually do this on your calculator. So feel free to refer back to the lesson 3.6 TI-84 video and use your calculator to fill in the table. Number 4 then says, all right, let's graph this information that we just made the table of. So I need a scale. My number of pizzas I need from the table to go all the way up to 30. So if I start by 2s, that should work. So we'll go up by 2s here, and let's go up by 20s on the vertical axis, the y-axis. So let's plot the points now that we had. Oh, we forgot to estimate. Number 3, they do tell us to estimate. We had $175 we could spend. $175 is pretty close to 180, so I can buy almost 20 pizzas, which aligns with the answer we found previously on the previous page. So back to our graph now. We're going to plot these and use the graph to estimate the number of pizzas we can buy. So we know that we had 0, 0. I know that 10 or 5 pizzas, 2, 4, 5, costs $45. So right about there. I know that 10 pizzas cost $90. 4, 6, 8, 10, 60, 80. Whoops. I know that 15 costs $135. Without having all my numbers marked, I actually have a hard time seeing this. 2, 4, 6, 8, 10, 12, 14 is 15. 20, 40, 60, 80, 100, 120, 140. It's right about there. So if you connect these, they do indeed form a straight line, especially if you're a little more accurate than I am. And then they ask us to estimate how many pizzas we can buy. So I know I've got $175 I can spend. Let's find where 175 would be here. So 20, 40, 60, 80, 100, 120, 140, 160, 180. So the number of pizzas is somewhere around here. I didn't continue my line far enough, which should give us roughly the same estimate of about 20 pizzas. Next time I graph this, I would write all my numbers in. I have a hard time counting each time without the numbers. Moving on to question number 5. It says we want to spend at most $175. This is a good place to use an inequality. So my equation that I had originally was 9p. That's how much it's going to cost to buy all these pizzas. If I want to spend at most $175, what kind of inequality should I put between these two expressions? I want 9p to be less than or equal to 175. How do I solve that? I solve it by dividing both sides by 9 and getting p is less than or equal to 19.4. So the same thing we have found several times, that I can order up to 19 pizzas and still be under budget. Moving on to page 377. They do throw a twist in a minute, not yet. On the problems we were just doing, keeping in mind our equation was c equals 9p, just to have it written here so I can refer to it. Number 6 asks me, what is the slope of the line we drew? Well, the slope of the line is what? 9. What does that 9 represent in this real life problem? It represents the cost per what? Per one pizza. What is the y-intercept of this line? The graph we drew in question number 4. Where does it cross the y-axis? It crosses the y-axis at 0, 0. What does that mean in terms of this real-world problem? It means that 0 pizzas cost me how much? Cost $0. Now we get the twist thrown at us in number 8. The author says, nice job so far, but did we forget to mention the $10 delivery charge? Sorry, you'll have to rework the problem. Keeping in mind that this is going to change how many pizzas we can get. We still want $175 as our maximum, $9 each per pizza, and now we have a $10 delivery fee. So the first thing they asked me to do is write the cost. How much are they charging me just to come to my house? They're going to charge me $10, regardless of how many pizzas they bring. Then I'm going to add to that the cost of pizzas, which is 9p. So this changes our table some now. I have to, and again, I can do this on my calculator like we referred to in lesson 3.6. 0 times 9 is 0, plus 10 is 10. So if I get 0 pizzas, it's going to cost me $10. 9 times 5 is 45, plus 10 is 55. 10 times 9 is 90, plus 10 is 100. Real quickly, compare that back to the other chart. The previous chart, we had 0, 45, and 90. Now we've got 10, 55, and 100. It's adding 10 to all the numbers from the previous chart. You can do that. You can continue to calculate it by hand. You can type the equation into your calculator and create the table on your calculator. Any way you'd like to do this, go ahead and fill in the rest of the chart. We should have 145, then 190, then 235, and 30 pizzas should cost me $280 with a delivery fee. I still have $175, so I want to use that to estimate how many I can buy. I can buy somewhere between 15 and 20. It's pretty close to being halfway in between. I would say maybe 17 pizzas, and that's, again, this is just an estimate. We'll solve the equation in a minute and see how many we can buy. Number 10 then says, let's go ahead and graph this. You can use your calculator to graph it, or you can graph it by hand. I am going to be a little more diligent about my scale this time. 2, 4, 6, 8, 10, 12, 14, 16, 18, and I'm going up by 20 again. So 20, 40, 60, 80, 100, 120, 140, 180. Just will help me graph it a little better. Graphing the points that we found in the chart just above. So I start with 0, 10. So about halfway through, or halfway between 0 and 20, I have a point. 5, 55. So 5 is going to be up around here. 10 is at 100. So 10 is going to be right on here. 15 is 145. So about there. 20 is 190. That's probably about as far as we can go. Go ahead and connect those, or again, you can use your calculator to graph them. We still have a straight line, but you'll notice it's shifted up 10. Again, I'm trying to spend $175. So go across. Just somewhere up here, pretty close up here. Kind of the same thing I found before, pretty close to that 17 pizzas idea. Turning the page to 378, they asked me to write and solve an inequality that can be used with this new fee with the delivery charge added on. So I know that my cost is $10 plus 9p. I still want to be under budget, so less than or equal to 175. That is the inequality that can be used. Now let's go ahead and solve that inequality. What do I do first to solve it? I would subtract 10. $9p is less than or equal to 165. What do I do next to solve this? I divide by 9. I'm running out of room. I write too big. P is less than or equal to what? Use your calculator to take 165 divided by 9, and we get 18.3. So what is the most number of pizzas I can buy? Well, I can't buy 18.3, so the most I can buy is 18. So the delivery charge affects how many pizzas we can buy. Number 12 says, is this a direct variation again? Well, one of the keys with direct variation is that it does have to go through the origin, 0, 0. Look back at our graph or our chart. Does our graph go through 0, 0? No, it does not. So this is not a direct variation. And we can explain it just by saying it does not go through 0, 0. No, does not go through 0, 0. Direct variation needs to be written as y equals k times x. And we can't write it that way because of the y-intercept. Continuing on, number 13 asks, what is the slope of the line I drew? That hasn't changed. The slope is still 9. What it represents has not changed. It still represents the cost per one pizza. What is the y-intercept now of this line we drew? Where does this graph cross the y-axis? Not at 0, 0, but at 0, 10. So the y-intercept of this new line is 0, 10. What does that represent? That represents the $10 delivery charge. On to page 379. We're going to wrap this up. It says, here's the key idea. This is number 15 on page 379. Here's the key idea. Look back at your answers to questions 8, 13, and 14. What was the slope? Slope was 9. What was the y-intercept? Y-intercept was 10. What was the equation? C equals 10 plus 9p. These are important values. You'll notice that the 9 goes with the variable and that the 10 is the constant in the equation. So that matches this equation. It says y equals the starting value of the quantity plus the constant rate of change times x. That is right here. This is known as the slope-intercept form of a line because we use the slope and we use the y-intercept, or the starting value. It's generally written as y equals mx plus b. We're writing it often as b plus mx. It works either way. So let's see if we can use this. Again, this is important. Let's see if we can write the equation of this problem they've given us. A small business had just 12 employees when they opened their doors, but they've been adding employees at the rate of $4 per month since then. Write a linear equation that describes the number of employees in terms of the number of months after the company was founded. So the number of employees is, how many did we start with? My starting amount was 12. How many am I adding? 4 per month. There's your equation. E is the number of employees, M is the number of months. What is the slope of that line? The slope is 4. What does that tell us? We're adding 4 employees per month. We can go ahead and graph this. We could graph this on our calculator. That makes life a lot easier. Or we could graph it by hand. I'm going to go by a scale of 1. And I'm going to go up by a scale of 4 here. 4, 8, 12, 16, 20. Writing some of them in to make my life a little easier. 3, 5, 7. So after 1 month, how many employees? Well, at 0 months, I have 12 employees. I know that. That's what I started with. After 1 month, I will have 4 times 1, which is 4, plus 12, which is 16. After 2 months, I will have 20. And again, you can do this in your calculator. You can do it by hand. 3 times 4 is 12, plus 12 is 24. So here's what my line looks like for my employees at this company. A straight line, but not direct variation again because the y-intercept is 0, 12. One more thing to look at on page 380. They wrap this all together here. How to graph an equation in slope-intercept form. You plot the y-intercept first, so it's on the y-axis. Step 2 is graph at least one other point. You can either find it by throwing a point in and calculating another point, or you can use the slope. and then draw a line through the points you plotted. I would recommend playing with your calculator and see how it graphs as well. Again, there's a video from section 3.6 that shows you how to enter these into your calculator and get them graphed. You should now be ready to start the 3.7 group work on page 380.